Hello everyone. Now we are going to discuss about the very important and popular theorem, Pythagoras theorem. How many of you wonder why we have to accept a square plus b square is equals to c square? Before going into proving the theorem, let's have a small conversation about the Pythagoras theorem. Pythagoras theorem is one of the most important theorems in mathematics. The usage is very wide and in every branch of the study it is useful. There are over 370 methods to prove this theorem. Today we are going to discuss two of them. One is using the similarity of triangles concept, and the second one is the most famous method, geometry method, which is named after the scientist Pythagoras. On the screen, we are seeing a right angle triangle, right? Let's name this triangle as A, B, and C. Now, let's name the sides. This one is A, this one is C, and this one is B. The side B is the hypotenuse, as it is opposite to the 90 degrees angle. Now, draw an altitude from angle B to the hypotenuse. This is the method one which I am going to use the similarity of triangles concept. Let's name the angle at A as x. Carefully observe in triangle ADB, angle D is equal to 90 degrees as BD is the altitude of the triangle. So angle ABD is equals to 90 minus x. As total angle at B is equals to 90 degrees, the angle DBC is equals to x, right? As both of them add together and give angle B, which should be equal to 90 degrees. If you observe carefully again, in triangle BDC, angle D is equal to 90 degrees, and the reason is same as BD is the altitude of the triangle ABC. As angle D is equal to 90 degrees and angle BDC is equals to x degrees, so angle at C should be equals to 90 minus x. I am writing this from the concept sum of angles in a triangle is equals to 180 degrees. Now using these triangles ADB and triangle BDC, I am going to write two pair of similar triangles using the concept angle-angle similarity. Angle-angle similarity says if two angles in the corresponding triangles are equal, then those triangles are called similar triangles. In similar triangles, the ratios of corresponding sides are equal. Now, I am going to prove triangle ABC is similar to triangle ADB. I already said, right? I am using the angle-angle similarity. If I can prove in both these triangles, two angles are same, then these two triangles are similar. In angle ABC, angle B is equal to 90 degrees. In triangle ADB, angle D is equal to 90 degrees. We prove one of the angle is equal. And in triangle ADB, angle A is equal to x degrees. In triangle ADB, angle A is equal to x degrees. So, triangle ABC and triangle ADB are similar. Now, the second pair of triangles I am taking is angle ABC is similar to triangle BDC. In this triangle, angle at B is equal to 90 degrees. In BDC triangle, angle at D is equal to 90 degrees. In triangle ABC, angle at C is equal to 90 minus x degrees. In triangle BDC, angle at C is equal to 90 minus x degrees. So, we are able to prove triangle ABC and triangle BDC are also similar using the concept angle-angle similarity. Using these two pair of similar triangles, we are going to prove the Pythagoras theorem now. As we came to know, these two pair of triangles are similar triangles. Try the ratios of the corresponding sides. For your understanding, I separated the triangles and draw the pair of the similar triangles. So, from these triangles, we can write ratios of the corresponding sides as from this first pair of triangles, we can write AB by AD is equals to AC by AB. It means C by B minus Z is equals to B by C. In the second pair of triangles also, we can write AC divided by BC is equals to BC divided by DC. So, B by A is equals to A by Z. If we cross multiply on both these equations, we will get C square is equals to B times B minus Z. In this one, we will get BZ is equals to A square. C square is equal to b square minus bz. Here we get bz is equals to a square, right? We can substitute this bz in this equation. We will get c square is equal to bz minus a square. If we are taking this equation to this side, c square is equal to b square minus a square. I am taking the negative a square to the left hand side, it will become positive. So a square plus c square is equals to b square. This equation might not be look like the conventional a square plus b square is equal to c square formula. I derived like this because how we have to remember the Pythagoras theorem is square of the hypotenuse is equals to sum of squares of remaining sides. It's not a square plus b square is equal to c square. In all the times, the side C might not be the hypotenuse. That's the reason I named the triangle in this way. Now, let's get into method 2. This is the geometry method, which is the famous Pythagoras method. In this method, the construction of the diagram is there are two squares. How they have to be arranged is the inside square should cut the outside square into four triangles 1, 2, 3, 4, and those four triangles are right angle triangles. As we know, at every vertex of the square the angle is 90 degrees, and there is one square also. This is the construction of the diagram. The length of the side of the inside square is c. As in squares all sides are equal, so all the side lengths are same as c. Let's consider one of the four triangles. As I already said, this is a right angle triangle, as all the vertices in the square is 90 degrees. Let's name this triangle sides as A and B. So in this right angle triangle, the base is B and the altitude is A and the hypotenuse is C. So the remaining part of this side will become A. Now this side will become B, this side will become A, and this side will become B, and this side will become A, and this side will become B. Now area of outside square is equals to a plus b whole square, right? As the area for the side square is s square, where s is the length of the side, and here the s is a plus b. Because of the internal square, the area of the external square is divided into four right angles triangle and one square. So the area of the outside square should be equals to area of four right angle triangles plus one square. So let's find the area of the four right angle triangles and one square and equate it to the area of the outside square, a plus b whole square. So a plus b whole square is equals to area of four right angle triangle plus area of square. This square is internal. We know the area of triangle formula is half times base into height. Here base is b and height is a. So plus area of square. The length of the side of internal square is c. So the area of the square is c square. It is equals to 2 times ab plus c square. We know the expansion of a plus b whole square, right? A plus b whole square is equals to a square plus b square plus 2 times ab. In both the sides, 2 times ab is common, right? So I am cancelling both of them. So a square plus b square is equals to c square. In this figure, in the triangle which was shaded into the blue color, if you see a and b are sides of the triangle and c is the hypotenuse. Square of the hypotenuse is equals to sum of squares of remaining sides. This is the Pythagoras theorem and hence it is proved.